Hello students, welcome to the class of teacher Meenal Pereira. In this video, we are going to study about regular fire extinguisher, its structure, working, and also we are going to study about the first hydrocarbon, that is methane. So let's begin. Okay, now children, you all are aware about fire extinguisher. You all know that it is used to extinguish the fire. So this type of instrument you must have seen in hospitals, or sometimes we even keep at home. So this is a very portable, very handy instrument which is used to put off or to put off the fires on a small scale. Okay, so let's study what is the structure of it and on what principle it works. Now coming to the internal structure of fire extinguisher. A fire extinguisher contains sodium carbonate powder. There is also a dilute sulfuric acid placed in a glass capsule. Okay, so you can see that this is a capsule in which dilute sulfuric acid is kept and a powder of sodium bicarbonate is kept here. Now we all know that we have just now studied, or we have that carbon dioxide gas is used in fire extinguisher. So basically these are the chemicals which are going to react with each other and are going to give out carbon dioxide gas. Okay, now you know why it is kept in a capsule, because we want the carbon dioxide gas to come out when required. As you all know that it is very difficult to store the gas. So directly we cannot store carbon dioxide gas. So a chemical reaction is going to take place that is going to release carbon dioxide gas, and that gas is going to extinguish the fire. Now let's see how the reaction works or how the process takes place. Okay, so what happens is here there is a knob or a pin. Okay, so when you pull the pin, okay, it presses a valve, or it presses the what you can say the valve of the capsule. The capsule bursts or breaks, or it then what happens is, what is there inside is sulfuric acid is there. This sulfuric acid get mixed or comes in the contact with sodium bicarbonate, and they two react and they give out the carbon dioxide gas. Okay, so after pulling the pin, there is this capsule breaks open, there is a contact between the chemicals, and the carbon dioxide that is released come out from the knob, and that could be used to extinguish the fire. Carbon dioxide based fire extinguishers do not cause any corrosion and are non-conductors of electricity. Therefore, these are used when electrical and electronic equipment catches fire. Okay, so any electrical instrument catches fire. If you put water, you all know that water is a good conductor of electricity. So then it will cause more problem. So carbon dioxide, because it doesn't support or it doesn't carry electricity, we use it in this type of electrical instrument. Then we have the carbon dioxide based fire extinguishers are also used to extinguish fire on small scale. This I already told you. It is beyond their capacity to extinguish a big fire, because once the reaction is over, then the entire carbon dioxide is over. Then for big fires, that much is not sufficient. In modern fire extinguishers, liquid and solid carbon dioxide is filled under pressure. Okay, so for that also, because carbon dioxide is a gas and we cannot store it for a long time, scientists have found one more solution. So we all know that under pressure, when the gaseous stage or gases are put under pressure, we can convert it into liquid or solids, and that can be stored. On reducing the pressure, it becomes gaseous again and comes out forcefully through the horn-like house pipe. Okay, so under pressure, we are putting it in a liquid or a solid state. Pressure is removed, again the liquid state is going to go in a gaseous state. It is very similar how we have our LPG cylinders. You all know that in LPG cylinder also, carbon dioxide is put in a liquid state and under pressure, and then the pressure is released, it comes out as a gas. The chemical reaction is the sodium bicarbonate reacts with sulfuric acid. It is giving sodium sulfate, water, and the main product, that is carbon dioxide. So different type of fire extinguishers are used. You can collect more information and how it is used. Further we move to methane. Methane is the first hydrocarbon, as I told you. Methane, its molecular formula is CH4. That means it has one carbon atom This is the 1 carbon atom and 4 hydrogen atom. Its molecular mass is 60. Then occurrence, how it occurs it? Methane occurs in natural gas up to 87%. The natural gas that we are using, it has 87% methane. Decomposition of organic matter in the absence of air, that is anaerobic, also produces methane. So any organic matter that dies and decomposes in less air gives out methane. Then methane is also present in a biogas. The biogas that we are used, that is produced by animal dung, methane is present there. Then it is also found in coal mines. In coal mines, we have studied about coal. So in coal mines also methane is present, and it is also found at the surface of the marshy place. Marshy places means, as you can see in the diagram, water is there. Okay, so because of the water, this place is always wet. So decomposition of the organic matter will cause release of methane gas. And because it is found in marshy place, it is also called as marsh gas. So this is how methane occurs. Then in the laboratory, suppose I want to produce methane, then how I can do that? On heating a mixture of hydrogen and carbon monoxide gas at 300 degrees Celsius, in the presence of nickel as a catalyst, methane gases form. Okay, so in the laboratory at 300 degrees Celsius, when hydrogen and carbon monoxide gas is heated, the nickel as a catalyst that fastens the reaction, the methane gas is produced. Okay, so this is means practical how we arrange the instrument. Okay, then 300 is a very high temperature. Okay, but just to give you an idea how it is prepared in the laboratory, a boiling tube where the gases are mixed and the delivery tube, and then we get the gas. Then fractional distillation of natural gas gives methane in pure form. Okay, so this is called as fractionating column. Basically, fractional distillation is used for petroleum products, because petroleum product contains petrol, diesel, coal, tar, methane. So everything, each one is separated at different temperature. So this is called as fractional distillation column. So when we use this fractional distillation of natural gas, methane is given out in the pure form. Okay, so thus methane is obtained by various ways. Then physical properties of methane, its boiling point is minus 182.5 degrees Celsius. Sorry, its melting point is minus 182.5 degrees Celsius. Its boiling point is minus 161.5 degrees Celsius. It is a colorless gas. The density of liquid methane is less than that of water. Density means weight. Okay, so since the density is less than that of water, you can see here, see in this one, this is of water. Okay, so when the density is less, that means it is lighter than water. So when methane gas is released, it is collected here. Okay, so density is less, so it is collected in the water column. Methane is sparingly soluble in water, and it is highly soluble in organic solvents like gasoline, ether and alcohol. So it is sparingly soluble, means in sufficient quantity it is soluble in water, not too much also, not too less also, but it is highly soluble in organic solvents like gasoline, as ether and alcohol. These are the hydrocarbons, other hydrocarbons. Alcohol you know. Okay, gasoline is a fuel. Methane is in gaseous state at room temperature. It's a gas, so it is in gaseous state. Now, chemical properties of methane is, it's a highly inflammable gas. It burns by reacting with oxygen to give bluish flame. And in this reaction, almost 213 kilocalorie per mole of heat is given out, and methane burns completely. Okay, so in our natural gas or many of the fuel, methane is used. It is highly inflammable. It burns with a bluish flame, as you can see, and it burns completely, no residue. The chemical reaction is CH4 reacts with oxygen to give carbon dioxide, water and heat. This is an exothermic reaction where heat is given out. Then there is one more property of methane which is called as chlorination. So methane and chlorine gas reacts with each other at a temperature of about 250 to 400 degrees Celsius in the presence of UV light and form mainly methyl chloride and hydrogen chloride. So this reaction is called as chlorination of methane. Okay, and this chlorination reaction or chlorination of it is a very important industrial reaction which is used for various industrial products that are related to chlorine. So that is chlorination of methane. So methane CH4 plus chlorine Cl2 in the presence of UV light gives us methyl chloride and hydrochloric acid. So this is an important industrial reaction. Then uses of methane, it is used as a natural gas in the fabric mills, paper mills, food processing, petrol purification. It is used as a fuel. This is the smallest hydrocarbon. The proportion of carbon dioxide released in the combustion of methane is small, and therefore it is used as domestic fuel. Because more the amount of carbon dioxide, more air pollution, so we use methane as a fuel. Then it is also used for the production of other organic compounds such as ethanol, methyl chloride, methylene chloride and acetylene. All these are other organic compounds which are used for various chemical reactions. So methane, first member, very important. It gives a clean fuel and it is used in the production of various other organic compounds. Next we move to a biogas plant, because methane is one important constituent of biogas plant. We are studying here biogas. You are having fair idea about biogas plant. You all know that animal dung, dry leaves, wet garbage are decomposed by anaerobic microbes in the biogas plant. Anaerobic means in the absence of oxygen. And this produces methane gas, which is also called as biogas. And biogas is a very cheap fuel which meets the demand for cooking gas. Okay, so in villages where they have a lot of animals, they have the biogas plant. Methane is made there. It is used for domestic purposes. So at least it is saving our LPG or stress on the natural gas. It is not only for domestic purposes, but it is also used for the production of electricity. Biogas contains about 55 to 60, that is high percentage of methane, and rest is carbon dioxide. So it is a very convenient fuel to use, and also it gives a good manure which is could be used for fertilization. Then biogas production process. Okay, so biogas production is an anaerobic process. Then this is a kind of biogas plant. Okay, so this is an inlet or chamber where all the dung and water is mixed. Then it is kept for a long period of time. This is called as a digester tank. Then this is an inlet. This is an outlet chamber. And this slurry is what is the manure that is left over. And then from here we get the gas. Okay, so the first process is production of acids. The microbes acts on the biodegradable complex organic compound and it produces organic acids. And then methane gas production. The methanoic bacteria acts on the organic acids to produce the methane gas. Okay, so in this digester tank, the microbes or microorganism first acts on the biodegradable compound that we are putting from here, and it produces organic acids. And then the second step is the actual production of methane gas. The methanogenic bacteria, these are the special type of bacteria which acts on the organic acid and produce methane gas. And as I said that from here the gas is exited, and then with the help of pipeline it can be taken. This is an overflow tank. Okay, so from here the slurry could be removed, and this is a cover. This covers the our entire, you can say, plant, so that the gas does not escape out. And this is a slow process. It takes time. Okay, production of methane gas, it's a slow process. It takes time. Okay, so I hope you are clear with this lesson. This is a very important lesson. Okay, please study it very well. There are various things that we studied in this lesson. Okay, first we studied about carbon. Then we studied about the allotropes of carbon, crystalline form, diamond and graphite, fullerene, non-crystalline form, coal, coke and charcoal. We studied the properties and uses of each. Then we studied about the hydrocarbons. which is a compound of hydrogen and carbon. Okay, then we also studied about carbon dioxide gas. Then after carbon dioxide gas, we studied about the fire extinguisher, and then we studied about methane. That's the first hydrocarbon and it is used in the production of various other chemicals. And lastly, we studied about the biogas plant and how biogas is produced. Okay, so this is your teacher Meenal Pereira signing off for lesson number carbon compound. Goodbye and take care. Thank you very much.